Okay. Hello. My name is Daniel. This is my semester project for geospatial programming. And this project, the goal of this project was to kind of like help to find like ancient sites. In particular, this analysis was done in a place in Nevada called Lake Lahontan. It's a kind of like a prehistoric lake that kind of like evaporated through thousands of years. And they found like petroglyphs on the shore of this lake. So like what I did was I got the elevation um, of this site and then used it to find the shoreline of the ancient lake. So um, first, like my first goal of this was to use this elevation to intersect with roads. So I was gonna have like an intersect function that could find and then give you the coordinate of the roads, but that like seemed to be a lot harder than it's easier said than done. And so I evolved my goal. So my goal too is just to show like a hill shade, like put a coordinate point, and it's gonna make a hill shade of that area. So pretty much you could like input a coordinate and then it'll show you kind of, it's like a reconnaissance tool, like kind of show you how the terrain is that area, because a digital elevation model is very large, like for example here, let's see this data set right here. This is all of Nevada. Okay, and this is a 30 meter resolution data set. So like in order to run a hillshade function or anything, you'd want like a smaller kind of area. So it evolved from there to then just clipping a digital elevation model from a hillshade. So pretty much subsetting. Okay, sorry, I had to pause. Okay, so yeah, where was it? Okay, yeah, so show the hillshade of a clipped area. So pretty much that's what it went to. Subsetting the data set. So let's run through this one. This is just going to go through, this is going to extract our source DM, the large one, and it's going to get the georeference, get the size. So that way we pretty much know what we're working with. So here's going to run. This should give us everything right here. Okay, so here gave us all this information. Its resolution, 30 square meters. Here's the extent. And it even gives us the mean elevation. So that's just the cell values of the digital elevation model. So let's continue, and it's going to go down here. So now what it's going to do, it's going to go through, it's going to offset the frame. So we have a frame of about 5,000 by 5,000. That's the window. And then it's going to move it 8,000, 80,000 off the X and 50,000 off the Y. So it's going to go boom, boom, down. Okay, and it's going to get us a good subset of data that we could run a hillshade with. So let's run to that one. Okay, so pretty much what we got now is it clipped our data set, and we could go over here, we could check this out. Let's load it in the QGIS. So there's our new clip today, 10:23 a.m. Boom, open, add, close, and there it is. There's our clip data set. So boom. So that would be an easier to process for a hillshade function. So let's go back to Python. And now it's going to call an earthpy that's going to take the clipped raster, and it's going to pretty much like visualize it for us in a few methods and then give us a hillshade so we can kind of see the terrain. So let's finish off this code. And it's running. And yeah, like even though it's a subsetted data set, it's still pretty large for the program. But like pretty much what it does is it takes the raster, takes the cell values, it breaks it down into an array like mathematically, to where it's like there's the X and the Y, and then each cell has a elevation value. So that's pretty much what I think matplotlib could do. yeah, here's PLT. So that's going to take the values, and that's what's making the digital elevation model. So that's why it needs to go in here. It needs to get the band and convert it to an array each time. And hopefully this goes. If not, as this is loading, I have another portion of this lab. So this part is in the terminal operation. So this is pretty much a raster calculator right here. So this is going to take the DEM. This is going to take the whole DEM and get every value below 1200 meters. So here, let's copy this into, let's go in the terminal. And actually I have this already completed, so I'm just going to go up. So here's the calc pi. And right here we got below 1200, and it's taking this Nevada DM, so it's taking the whole data set. So let's run that. So now we got terminal running, and we got Python, so hopefully the computer doesn't crash. Okay, so both of these are loading now. Computer's fan is going. And here we see in my Python. Oh yeah, so after this pretty much does a raster calculator. We're gonna use that raster generated to make a polygon shapefile. So the polygon shapefile is this is moving in the direction of my original goal of making a shape boundary that, okay, here we go. So Python's running. So here's our clipped DEM. Here is another one, just with a different color scale, but the same subset. And here is the hill shade of the subset. So pretty much you could kind of see, you know, the valleys and the mountains. And, you know, if as soon as I could get a dot in there to show you your site of interest, like that's just going to be like, I'm going to be so close to my final goal. But, okay, let's see this one. This one has ran already. So let's go in the queue and let's see this. So this is a raster data set. So this will be not in the data file. So semester project. And here is the 1200 full. And some coordinate issues. Okay, should be on. All right, sorry, yeah, I'm at work right now, so COVID times, you know. Okay, so here, let's just change the symbology really quick. There we go. I still don't want to do it. Okay, so there we go. We can see a little bit better. So that's below. So then we have our Lake Lahontan region right here. Boom. Even went a little bit into the raster. So that's kind of cool that the subset of data set got a little bit of Lake Lahontan, because all this is an area of interest. So this is the ancient lake. There's sediments found in this lake. So this is why we're going after this. So let's go right here. Let's get our shape file. Okay, so this is a polygonize. This is just using GDAL. So we're going polygonize. We're taking our raster and we're making it into a shapefile. So here we go. Let's run this. And this is in the terminal. So this is calling GDAL through the terminal. So sometimes the terminal is a lot easier because it just seems to like run a lot quicker. Okay, so it's finished. let's go. Let's take this one off and let's add a vector layer. Okay. Okay, this might be working. Strange out.shape. Out.shape must be full. Boundary full 2.shape. Okay, sorry. Alright, let's see what this is doing here. Out.shape, that's weird. It seems like it didn't work. Okay, actually it worked. It just didn't name it. It named a different name, so it's kind of strange, but here we go. Now we got a shape file. So now this shape file, say, it could be used with the road shape file. So let's add the road shape file just so you can see. And here is the roads. And yeah, so if we could get these roads to intersect, I mean, and then give us something, Python could do something with it for us, like, that would just be amazing, you know. So that's the next on my goal. But yeah, so pretty much we took a raster DEM, subsetted, made a hillshade, raster calculator through the terminal, and convert it to a shapefile. And then now would be to get some intersect tools with this and see where these roads are near possible ancient sites and go from there. Awesome. Thank you so much. This is my presentation. Goodbye.